Hi, I am Alexis Macy S. Magda, and I'm here to teach you about 2D plotting. Now that we are done introducing the basic MATLAB, let me introduce 2D plotting. 2D plotting allows us to control the range of x and y values displayed on a plot, to lay multiple plots on top of each other, to create multiple figures, to create multiple subplots within a figure, and to provide greater control of the plotted lines and text strings. So let's have an example first. Our x is equals to 0 with the increment of 0.2 with the last digit as 100, semicolon, and then our y value is y is equals to 2 times x two and then semicolon, and then we plot this x and y values. This is the output. And then let's have the title of linear plot. And then let's put the x label as x. Then our y label is y. So that's how you use the plot command here in MATLAB. So now let's proceed to logarithmic scales. It is possible to plot data on logarithmic scales as well as linear scales. There are 4 possible combinations of linear and logarithmic scales on the x and y axis, and each combination is produced by a separate function. So we have first the plot we used earlier, which plots both x and y data on linear axis. And then we have the semi-log x function, plots x data on logarithmic axis and y data on linear axis. And then we have semi-log y functions that plot x data on linear axis and y data on logarithmic axis. And then finally, we have the log-log function that plots both x and y data on logarithmic axis. All of these functions have identical calling sequence. The only difference is the type of axis used to plot the data. So let's have an example in the MATLAB application. So here we are at the where we left off earlier, and this is an example of a linear plot. So you can see x-axis and y-axis. So let's now have the semi-log x. So we have an x and y value earlier. This is our x and y values. So let's have semi-log x and then parenthesis, and then x and our y values input, and then we close the parenthesis and semicolon. As you can see, the graph changed. So that is correct. As you can see, it is a bit different earlier. And then we can put the title, which is, like I said earlier, parenthesis and then a string. Let's have semi-log x graph. And then we put a string and then parenthesis and then semicolon. Let's also have x label. Let's have x, and then our y label is y. And you can also have a grid. You can turn it on by typing grid on. You can see we have a grid. So that's a semi-log x plotting. I also put earlier the plot. So this is the plot x and y, and this is the semi-log x y, semi-log x. You can tell the difference. So now let's have the next example, which is semi-log y. So let's type semi-log y, and then oops, x and y values, and then semicolon. It didn't put another figure, so it deleted the last one. So let's put another let's put the semi-log x here mamaya. So let's focus on the semi-log y. As you can see that it is reflected, like you can tell the x-axis was like this earlier, and then the y-axis is now here, ganyan. It is a parang reflection. So let's have a title again. Semi-log y graph, and then our x label is x. Our y label is y. So here is the semi-log y. Let me put the semi-log x graph that we deleted earlier, para you can tell the difference. As you can see, so here is, we deleted the plot, my bad. So let's plot here the x and y, the linear. Here you can see the difference. So this is the plot x and y. We put the title para di tayo ma-confuse. So here's the linear graph, and then here's the semi-log x graph, and here's the semi-log y graph. So let's go to the last function, which is the log-log. So let's put another figure for the log-log. So let's have log-log x and y values, and then semicolon. As you can see, it is a straight line. They are all different, as you can see. So let's have a title. Parenthesis. Let's have log-log graph. And then our x label is x, x, and then y label as pinaglo-load. There, and our y label is y. Okay, so now there you have the difference. So we have first the plot, the linear, and then the semi-log x, and then the semi-log y, and then the log-log function. So now let's have controlling x and y-axis plotting limits. By default, a plot is displayed with x and y-axis ranges wide enough to show every point in an input data set. However, it is sometimes useful to display only the subset of the data that is a particular interest. This can be done by using the axis command /functions. So here is the commands. These are some commands. We have the v is equals to access semicolon. This function returns a four element row vector containing the x minimum, x maximum, y minimum, and y maximum, where they are the current limit of the plots. So we have axis, parenthesis bracket, x minimum, x maximum, y minimum, and y maximum, bracket, close parenthesis, semicolon. This function sets the x and y limits of the plot to the specified values. And then we have axis equal. This command sets the axis increment to be equal on both axes. And we have axis normal. This command cancel the effect of axis equal and axis square. We have axis square. This command makes the current axis box square. And then we have axis off. This command turns off all axis labeling, tick marks, and background. And then lastly, we have axis on. This command turns on all axis labeling, tick marks, and background default case. So let's have an example in MATLAB. So here we are at the MATLAB application. So let's have our x as x is equals to -2 times pi with a stepping increment of pi over 20. And the last series for this series is 2 times pi. And then our y-axis is sin x. So let's plot the x and y values. There we go. And the title, let's say, is line graph. So let's try some axis function or commands here. Let's have the axis, parenthesis bracket. Let's have our x minimum as 0, our x maximum as 2, and then y minimum is 0, and then y maximum is 2, bracket, close parenthesis, and semicolon. As you can see, it's it transformed. And then if we type axis auto, it will go back to the previous graph that we in this figure. Tran. So that's how you use the axis commands and functions. So now let's try plotting multiple plots on the same axis. Normally, a new plot is created each time a plot command is issued and the previous data displayed on the figure is lost. The behavior can be modified with the hold command. After a hold on command is issued, all additional plots will be laid on top of the previous existing plots. So let's have an example here in MATLAB. So let's have our x as -pi, our first series, and then let's have the stepping increment of pi over 20 with the last series is pi, and then our first y value is sin x, and then our second value of y is cosine x. Now let's plot this um, this values, I mean this x and our first y value. So let's have x and then y1. And now let's put in use the hold on command. So let's type hold on. And then let's plot the second graph, which is with the x is y2. As you can see, we have two graphs in one figure. So that's how you use a hold on command. Now in MATLAB, there is called a subplots. It is possible. It is possible to place more than one set of axes on a single figure, creating multiple subplots. The general form of subplot is subplot with m, comma, n, and p, and then close parenthesis. The m is the rows, n is the column, and p is a set of axes at position to receive all current plotting commands. The subplots are numbered from left to right and from top to bottom. So let's have a example. So let's use figure 2 since we have a graph in figure 1. You can type figure 2 or just click this add button and it will add a figure. So let's have a subplot of 2 rows, 1 column, and the first position, which is 1, and then we enter. And then let's plot let's try this values. So let's have a plot x, y1. Here, it is the same in figure 1. This one, that is our x and y1. And then let's title it as subplot 1. And then let's have the other figure, which is subplot 2, 1, 2. It changed the p because since it is the second graph that we are placing. Now let's plot the x and y2. And you can see it is the same, but it is in different graphs now. So let's title it subplot 2. So that's how you use subplot commands. In MATLAB, you can also add colors, markers, and line style on your graph. The form of this is you plot the x and y data, and then you add the CML. CML stands for color, marker, and line style on that order. So here are the different types of colors, markers, and line style, and their symbols. So let's try some examples in MATLAB. Let's have an example here. So we have x is equals to 0 with the stepping increment of pi over 15, and then the last number is 4 times pi semicolon, and then our y value is the exponent of 2 times times sine x, sine x, semicolon. And then here we use the plot. So let's have the plot x and y, and then annotation. So let's have the color red. So let's put R. And then our marker, let's have a diamond. So D. And then our line style is dash dot. So let's have dash and dot. And then let's enter. So you can see the color of the line is red, and then the style, the marker is diamond, and then the line style is dash dot. So that's how you use the different symbols of colors, markers, and line styles in MATLAB.